Hi guys, we're going to start chapter 7.6 notes, which is the Similarity Transformation notes. So let's first start with some key concepts. So the first key concept is different types of dilation. A dilation with a scale factor greater than 1 produces an enlargement, or an image that is larger than the original figure. So if we look here, notice our smaller figure, our blue one, gets enlarged to turn into the green one because it was multiplied by a factor greater than 1. Well, the opposite is true. A dilation with a scale factor between 0 and 1 produces a reduction, an image that is smaller than the original figure. So let's go ahead and use this to look at example 1. So it says determine whether the dilation from A to B is an enlargement or a reduction. Then find the scale factor. So let's look at A. It says B is smaller than A, so this is a reduction. Reduction. The distance between the vertices, negative 3, 2, so negative 3, 2 is right here, and 3, 2, so negative 3, right there, for A is 6. And then we have to find what the distance for B. So this is what they're doing. They're counting. So 1, 2, 3, 4, 5, 6. And then this one is 1, 2, and then about, let's say, a half because of those little parts. So about 2.5. So then we have A is equal to 6 and B is equal to 3 because these halves right here are going to add to a 1, so that's technically 3. So if we divide 3 over 6, we get 1/2. So that is the factor of dilation. Let's look at B. B is larger than A, so this is an enlargement. Okay, now let's count the distance from A to B. So A, let's look at the sides here. We have 1, 2, 3. This one is 1, 2, 3, 4. So A is 3, B is 4. So we do 4 divided by 3, which is bigger than 1. So it's going to be like 1.33. So this is an enlargement. Okay, let's look at example 2. Refer to the beginning of the lesson. By what percent should Adriana enlarge the ticket stub so that the dimensions of its image are 3 times her original? What will be the dimensions of her enlarged image? So she wants to do something that is 3 times her original image. So if we were to write this in a percent, this would be 300% bigger because 100% is the original length and 300% would be the larger length. So all we have to do is multiply each of these sides by 3. So we have 5 times 3, which is 15 centimeters, and 6.4 times 3, which is 19.2 centimeters. So the new dimensions are 15 by 19.2. Okay? And then our increase, like we said, was 300% because you do 3 times 100% and you got 300%. Okay? So, dun, dun, dun. Yeah, and this is what it was looking for, the dimensions. Okay? Let's look at example 3. Example 3 has 2 parts, part A and part B. It says graph the original figure and its dilated image. Then verify that the dilation is a similarity transformation. Okay, so I already have it graphed for you. So what we need to do is we need to find the ratios of the sides so we can see if they are similar. So since angle C and angle Z are both right angles, we can say that angle C is congruent to angle Z. Now we need to show that the lengths are proportional. So xz over AC. Well, xz, if we count, is 1, 2, 3, 4, 5, 6. And AC, if we count, is, so this is what I counted first, and now this is what I'm counting. So this is 9. So 6 over 9 reduces to 2/3. Now let's check the other side. YZ over BC. Well, YZ is 4, and BC is 6, and this reduces to 2/3. Since these are similar, and they had a similar right angle, we can say that these are similar by the SAS similarity. So check SAS. Okay, let's look at the next one. So for this one, we need to show that all of these sides are corresponding. And we need to do that by finding the distance of each side. Well, notice this time we can't just easily count because now our objects are tilted and they're not directly on an axis that we can count. So we're going to have to use the distance formula and find the distance from each figure. Okay, so first we're going to find the distance from J to K. Excuse the noise, I'm going to tilt my computer. So from J to K, and I'm just going to be writing this out because you guys should have the distance formula memorized by now. So we have 6 minus negative 6 squared plus 8 minus 4 squared, and that gives us the square root of 160. Okay, then let's do PQ. PQ is the square root of 3 minus negative 3 squared plus 4 minus 2 squared. That gives us the square root of 40. Okay, now let's do KL. Square root of 8 minus 6 squared plus 2 minus 8 squared. So this gives us 1 square root of 40. QR is equal to the square root of 4 minus 3 squared plus 1 minus 4 squared, which is equal to the square root of 10. LM is equal to the square root of negative 4 minus 8 squared plus negative 2 minus 2 squared, which is equal to the square root of 160. RS is equal to the square root of negative 2 minus 4 squared plus negative 1 minus 1 squared, which is equal to the square root of 40. Okay, we have 2 more. MJ is equal to the square root of negative 6 minus negative 4 squared plus 4 minus a negative 2 squared, and that's the square root of 40. And then SP is the square root of negative 3 minus negative 2 squared plus 2 minus negative 1 squared, which is the square root of 10. So now we have to see if all of these match. Okay, so we have, sorry, I'm trying to change my color here. So we have a square root of 160 and a square root of 160. Okay, a square root of 40 and a square root of 40. Another square root of 40, another square root of 40. And then a square root of 10, a square root of 10. So since we have matching sides for each side, we can say that the proportions are all going to be similar. Because if we write the proportions PQ over JK, so PQ was square root of 40 over JK, which is square root of 160, well, that's going to simplify to 1/2. Similarly to QR over KL, so QR square root of 10, KL square root of 40. If we divide those by each other, we would get 1/2. And then you guys get the idea for the rest of them. So if we did proportions for every single one, that would be true. So this proves that these triangles are similar. Okay. Let's go ahead and look at, oh, I believe that was it. Yeah, that's it for 7.6. So the key factors here is the proportions based on dilation, and then to remember the distance formula. Okay.